Hello everybody, I'm Giacomo Fragione from Northwestern University, and I'm going to talk about repeated mergers and ejection of massive black holes within nuclear star clusters. Nuclear star clusters are among the densest environments in the universe. They have large masses and densities so large that black holes can efficiently form binaries and merge within a Hubble time. So the formation of binary black holes happens on a three-step process. So first, the binary forms over these timescales during a three-body interaction. Then the binary hardens as a result of the interaction with other compact objects and stars. And finally, the binary merges within a gravitational wave timescale when the separation is small enough. So whenever a binary merges, the remnant is imparted a recoil kick as a result of the asymmetric emission of gravitational wave radiation. This recoil kick can be as high as a few hundreds up to a few thousands kilometers per second. And if we want the merger remnant to be retained and merge again hierarchically, we need that this recoil kick is smaller than the escape speed from the nuclear star cluster. The escape speed from the nuclear star clusters is of the order of a few hundreds kilometers per second. So as you can see here, so in blue here, we have like some examples of these kick velocities. So there is a non-negligible probability that the nuclear star clusters can retain the merger remnants such that they can merge again, while this probability is quite small for globular star clusters. So now the recoil kick depends on the mass ratio. The smaller the mass ratio, the smaller the recoil kick, and on the spins of the black holes. So the smaller the spins, the smaller the recoil kick. And so the story about forming massive black holes through repeated mergers is the following. So you start with some seed. So this seed can be as high as a few tens solar masses. So if we trust the results of the evolution of massive stars, so this seed cannot be larger than roughly 50 solar masses. But we can think that there are larger seeds. So these seeds, as they merge with other black holes and are retained, so it grows in mass. So growing in mass, the recoil kick becomes smaller, and at the same time, the spin becomes smaller because, as I told you, the recoil kick becomes smaller for smaller spins. And so, given that, we can have a successful hierarchical growth of intermediate mass black holes or larger black holes, and during this process, we have a lot of intermediate mass ratio spirals that can be, for example, detectable by LISA. So what is the role of the nuclear star cluster mass and density? So the larger the mass and density of the nuclear star cluster, the larger the escape speed. However, so the more likely that we can have a hierarchical growth. However, if the mass, the timescales over which the formation and mergers of binary black holes happen are proportional to some power of the mass and inverse proportional to some power of the density. So this means that if the mass becomes larger, the escape speed becomes larger, but also the timescales for the process become larger. And so as you can see in this example, if the mass becomes too large of the nuclear star cluster, so we cannot form efficiently massive black holes because all the process happens over longer time scale. On the contrary, if the density becomes larger, so we can form efficiently massive seeds because both the escape speed becomes larger and the time scales over which the hierarchical process happen becomes smaller. So, and we can form in some cases black holes that are as massive as 10 to the 4, 10 to the 5 solar masses. What about the ejected black holes? So this is one of our runs, and as you can see, the most massive ejected black hole you can get is of the order of 600 solar masses. And the reason for that is that the escape speed becomes smaller for smaller mass ratios. So this means that at some point the seed has grown so large that anything is going to merge with will not be such that the remnant will be imparted a very large recoil kick, so it will be anyways retained within the nuclear star cluster. So I leave you my conclusions. That is, nuclear star clusters are massive and dense enough that they can favor and they can host the hierarchical growth of massive black holes, and so we can form black holes as massive as 10 to the 4, 10 to the 5 solar masses, and the black holes that instead are ejected are of the order maximum of 600 solar masses. Thank you.